Good afternoon, class. We are looking at Algebra Practice Test, Module 3, covering chapters 7 and 8. Here's chapter 8, Roots, Radicals, and Complex Numbers. So before we start, let's look at the concept. When we look at something like cube root of x, here's the sign, radical sign, and number 3 is the index, and what's inside is called the radical. Here's some formulas we've seen here. Exponential rules. This is the zero exponential rule, product rule, power rule, quotient rule, negative exponential rule, so on and so forth. One of the things I want you to pay attention is these two. If you look at these two, this one and this one, that are negative exponential, basically it says if you have a negative exponent, just move it. If it's up, take it down. If it's down, bring it up and change the sign. We have this concept of a positive principal root and a negative principal root, and that would be square root of x versus minus square root of x. So we put a negative in front of it. It's important to know when we say square root of 49, it is equal to 7. It's not plus minus 7. However, when we say x squared equals 49, then we have 7 and negative 7. So in this case, the number b is a square root of a. B squared equals a, or square root of a equals b. Understand that square root of a squared is the absolute value of a, not necessarily a, because when the index is odd, we have no restrictions, even we do. And this is explained here in the case of an odd root, the nth root of a or nth root of x, where n is an odd index and a is any real number, is called an odd root, and is the real number b such that b to the power of n is a. However, in the case of an even root, we read the same thing, the nth root of a written nth root of x, where n is an even index and is a non-negative real number, and that's the key, non-negative real number versus any real number. So with odd roots, no restrictions. With even roots, there's a restriction. Is called an even root and is the non-negative real number b such that b to the power of n equals a. In other words, if you look at the graph of y equals square root of x, which looks like this, the domain and range, domain is from 0 to infinity going this way, and range is from 0 to infinity going up. However, with the case of a cube root, we have no restrictions. The domain and range are both all real numbers. And another thing that might be helpful, you all know that cube root of 8 is 2. Cube root of negative 8 is negative 2. That's not a restriction. But if you have square root of minus 4, you say it's not a real number, or you say it's 2i. And that's the idea. So the conclusion is the domain of a radical function are as follows: with an even index, values that keep its radicand non-negative. With an odd index, all real numbers will do. So that is the synopsis of something that I thought was helpful before we start. So let's go with this question. Whenever we have a negative exponent, there are various ways of dealing with that. In this case, we flip this over to the power of 1/2. Which means the square root, 16 comes out as 4, 25 comes out as 5. So let's take a look at what we have here. A to the power of m over n is the nth root of a to the power of m. In other words, the denominator is the index and the numerator is the exponent, and you can write it either way. If it's negative, it goes down. So with that being the case, we are going to write it with this format, And we all know that cube root of 8 is 2, 2 squared is 4, 1 over 4 is the final answer. In this case, both numbers come out, and 9 over 13 is our final answer. In this case, first let's put them together by writing it as one radical. The other one that I want to tell you that each piece comes out, 4 comes out as 2, x cubed comes out as x and x remains, y cubed comes out as y and y remains. How does that work? 4 is clear, but basically, if you happen to have an exponent, in this case 3, you divide it by the index. Remember, when we don't write the index is 2, and it becomes 1 with the remainder 1. The same thing happens with y. So you bring the quotient, which is 1 r, which is 1, out. So you bring 4 out, and then x cubed, one of them out, one of them in. Which one is out? With the exponent quotient as the exponent. We're going to rewrite this because 24 and 2 becomes 48. Now, this may not be that clear. That's why I chose to try this one for you and show you the method I just mentioned. How do we deal with that? I want to show you an easy way. I hope you know this is 2 to the power of 6. So we are going to deal with it in the following manner, everybody. Number 6, if you divide it by the index, which is 5, you get 1, 1. Therefore, 2 to the power of 1 comes out, 2 to the power of 1 stays in. For x, 10 divided by 5 is 2. That is the quotient. There is no remainder, so x squared. Number 23 is the exponent on y. You divide by the index 5. You get 4 with the remainder 3. The quotient comes out, y to the power of 4. The remainder 3 sits inside. If you could do this, I can't imagine you having any problem with any questions of this form. Divide the exponent by the index. The quotient comes out, the remainder stays in. The reason why is if the index and the exponent happen to be equal, it just simply comes out. That's why you divide by the index to see how many of them there are. To do this, let's put them together. So when we multiply these two, we get 20x y cubed z. We just write the bottom. And now we can get rid of what's in common. 20x and 20x are identical. Z and z. So we have y cubed divided by y, which gives us y squared. And it's y if you know it's positive, otherwise it's an absolute value. Please understand it's an absolute value unless you know for sure the variable is positive. So depending upon what they tell you in the question. This is clear, 20 divided by 4. And there you have it. Again, we put it in an absolute value, or if we know it's positive, we don't need that. We want to raise this to the power of 2/3. There are a couple of different ways to handle it. One easy way is to simplify the fraction first as follows. You just change this to 27. For this part, notice both of them are negative. You have two choices. You can bring a to the power of negative 2 up, becomes a to the power of positive 2 and deal with it that way. Or you can bring a to the power of negative 2 up and take a to the power of negative 3/4 down. Both of them make it positive. And obviously, the last one gives you b cubed. So one way to do it is this. You can keep this and you can bring this one up and deal with it this way. Now we're going to raise everything to the power of 2/3. To do that, first and foremost, we notice these two, we can write them as a to the power of minus 3/4 plus 2, which is a to the power of 5/4, because 2 is 8/4. Now let's write each one to the power of 2/3. So 27 to the power of 2/3. 27 to the power of 2/3. This one to the power of 2/3, that means multiply these two, which is 10/12. And when you raise b cubed to the power of 2/3, you get b squared. If you want, I can write the intermediate step as follows. So you can write 27 to the power of 2/3, a to the power of 5/4 times 2/3, and b cubed with the 3 times 2/3, which gives us the following. Now we know 27 to the power of 2/3 is cube root of 27, which is 3 squared, and it becomes 9. We also know that a to the power of 10/12, we can simplify to 5/6. And that's the final answer. So this becomes 9, and 10/12 changes to 5/6. B squared remains unchanged. If they say divide, simplify, or rationalize, it means the same thing. When you have a case like that, you really want to get rid of the radical. Notice the index is missing, therefore the index is 2. You multiply it by itself, meaning square root of 5. The reason you do that, because the index is 2, and if 5 is to the power of 2, it can come out. That's the reason. That's why you multiply it by itself. So this comes out, and the top remains unchanged here. 5, 3 and 5 is 15. 5 and 5 cancel each other. And we are done. I want you to compare A and B. Notice in part B, the index was missing. That means 2, and we had to use the same thing. In this case, the index is 3. And again, in order for this to come out, every exponent must be equal to the index. 5 has an exponent of 1 when it's missing. Y has an exponent of 2. So this, for it to come out, should become 5 cubed. So we need 5 squared for that. But this one only needs Y. So pay attention just to the bottom. And notice when you multiply, just look at the bottom for now only. In essence, you're doing 5 cubed, Y cubed, the cube root that comes out as 5Y. And because this has to be justified, you put exactly the same thing in the numerator. So this comes out as 5Y, and the top, you just write it and you change the 5 squared to 25. You don't want to leave it as 5 squared in this case. We want to simplify or divide or rationalize. It means the same thing. We multiply by the conjugate of the denominator. Remember, conjugate of A plus B is a minus b, so you get a squared minus b squared. And the denominator, the conjugate is simply square root of 2 plus square root of 3, so you multiply and divide by it. Bear in mind, this fraction is equal to 1. So we're going to multiply the bottom using a squared minus b squared. Simply put, the bottom comes out as 2 minus 3 using that. But this one, you have two choices. You can do the foiling, or notice it's a plus b quantity squared. So let's write that again for everybody. A plus b quantity squared is a squared plus 2ab plus b squared, where a is square root of 2. So you square that, you get 2 plus 2 times the first times the last is 2 square root of 6. You square that and you get 3. So I hope you see what I'm doing here. I'm using this, or you can foil it, either way. The denominator changes to negative 1. And we have 5. So we have 5 plus 2 square root of 6 divided by negative 1. When the denominator is negative 1, we don't keep it. We change everything to a negative sign. We do the same thing here. We want to rationalize or divide or simplify. We multiply by the conjugate of the bottom. And to justify it, we have to multiply and divide by it. So the bottom clearly, remember what we get, a squared minus b squared. We get 6 squared, which is 36. And this comes out as x. And this is just the product of the two. You can keep it as a product, or you can distribute, makes no difference. Many times it's a good practice to, in fact, keep it as a product in case it gets simplified. We want to solve and check, even if they don't say check, you must check whenever you're dealing with a rational equation or a radical equation. The very first step is isolation. Step 1, get rid of the 7. Step 2, raise both sides to an appropriate power. In this case is 2. So this simply comes out. This is x squared minus 2 times the first times the last minus 14. X plus 7 squared is 49. We bring everything to the right side because it's x squared on the right side. That's why we do that. So let's move this, make it minus 2x. Move this, make it minus 1, giving us x squared, minus 16x plus 48, and we factor it such that the product of two numbers is 48. Their sum is negative 16. Negative 4, negative 12 creates the answers x equals 4, x equals 12. Now, how do we check only with the original equation and nothing in between, because things could have happened in between? So plug in 4. And so what happens here? 2 times 4 is 8 plus 1 is 9. And therefore it comes out as 3 plus 7, 10 is 10 equals 4. No, therefore 4 is out. That's why you check. 4 didn't work. Let's do 12. 2 times 12 is 24, and 1 becomes 25, comes out as 5. Is it equal to 12? Yes, it checks. This is an acceptable answer. So that's why you check it always. Now, speaking of I, let's go over a few things to remind everybody what we know about I, starting with the definition of I, which is square root of negative 1. If you square it, you get negative 1. I cubed, that means I times I squared makes it negative I to the power of 4, you can square I squared and it becomes positive 1. Complex number is in the form of a plus bi. Square root of negative 1 is I, so square root of negative n is I squared of n. It's important to put the I outside the radical or it is wrong. When we multiply these two, remember a plus b times a minus b gives us a squared minus b squared. This one gives us a squared minus b squared I squared, and I squared is negative 1. That's why we get plus. So that would be the synopsis of what we need to move on. How do we simplify that? We went over this and we notice I to the power of 4 is 1. I to the power of 4 is 1. Therefore, if it's I to the power of powers of 4 is multiples of 4, it's also 1. So even if I have I to the power of 8 or I to the power of 80 or I to the power of 800 or I to the power of 40, all of them equals 1. So with that being the case, what is the best course of action? It's very simple. Divide this exponent by 4 and keep the remainder. In this case, remember, a number is divisible by 4 if the last two digits is 24 is divisible by 4. So when you divide it, it gives you remainder 1. So it's I to the power of 1, which makes it I. Part B, flip it over. 6 divided by 4 is 1. It's not important. It is the remainder that is important. So 1 over I squared. We know I squared is negative 1. That's the answer. I hope everybody's okay with that. I'm going to give you one more example because I want to make sure you're comfortable with that. So if I happen to have I, let's say, to the power of 43, I hope you know when I divide 43 by 4, the remainder is 3. So I get I cubed. Therefore, negative I. All right, we want to simplify or rationalize or put it in a standard form. However they call it, that simply means the same thing. So we're going to multiply by the complex conjugate of the denominator, which is 3 minus 2i. We're going to multiply the top and the bottom. The reason why, because the bottom comes out according to this 3 squared plus 2 squared, makes life easy. And this all you have to do, distribute or FOIL. 5 times 3 is 15, minus 10i, minus 6i, minus and minus becomes plus 4i squared. In fact, imagine is x and just write everything. Needless to say, I squared is negative 1. This becomes now minus 4. (15) and negative 4 give us negative 11. They add up to negative 16i. 9 and 4, they add up to 30. Now, if you left it as that, it's not that big of a deal. But if somebody asks you what is A, what is B, you should be able to answer. If you can't, you must rewrite it in this fashion because A is 11 over 13, B is minus 16 over 13. This is the value of A. This is the value of B, including the sign. So negative 16 over 13. We want to simplify this. And again, we do 39 divided by 4. And I hope you know the remainder is 3 because 36 is divisible by that. So it's I cubed. And I cubed is negative I. That's the reason. Divide by 4, keep the remainder. That's the fastest way. We want to add this up. So 20 minus 5i minus 12 plus 3i plus, change this to 10i. (20 minus 12), that gives us 18, minus 5i, plus 3i, plus 10i, that's 8i. We want to multiply, we need to do the same thing, meaning we need to change this to 2i and this one to I before we move on. Now we're going to distribute FOIL. This is 3, this is 3i, this is 2i, this is 2i squared. And we know this changes to negative 2. Number 3 and number negative 2, they add up to positive 1. 3i and 2i, they give us 5i.